going to be demystifying and learning all about how to read atoms on the periodic table. So here's our periodic table. We don't have our noble gases, thanks to my printer. So go ahead and get that put back up on the board. All right, so the first atom that we're going to be dealing with is actually chromium. I'll pull that off of here for you real quick. Chromium, there we go, let's take a look. All right, so right here we have 24, which is our atomic number, and down here we have 51.996, which is our atomic mass, okay? Quick lesson before we get into things. If you see an atomic number like this, you can round it up to 52, okay? All right, let's get started. So we're going to start with chromium. Chromium is one of our transition metals, and that means that its outermost electrons are located in its d-valence shell. They're not overly stable. Most of them tend to be isotopes. It is very, very important to know where things are located on your periodic table. Actually, quick service announcement before we begin, and then I will get into it. If it takes flashcards, if it takes music, if it takes taping it to the front of a binder and looking at it every day lovingly, get to know your periodic table. It's your best friend. You should know your rows, your columns, you should know your family groupings, because the sequential atomic number, which goes from left to right, tells us how many protons are in that atom. And we know that atoms that have a similar amount of protons generally act fairly similar, and that when we group them, we also group them in ways that they react. So we know based on their rows, columns, and groupings what to expect if we are performing a chemical reaction, and that's important, and it will save you a lot of time in the future. Also, know your symbols, because as you get further along in chemistry, the tables tend to have more numbers included. It gets a little more complicated. They're not going to waste time with the chemical name, because you should know it by the chemical symbols. So learn your chemical symbols. In time, the atomic number and the mass and all of the characteristics of every atom will become second nature, because you will do it so much. You will look at the periodic table so often, it will be like a best friend, which should be. Okay, so no more preaching, no more soapboxing, but please know it. Let's begin. So we're doing chromium, but I'm going to use this lithium because it is not taped to my board, and so I can show you what number I'm dealing with. So first we're going to look at the atomic number. Remember, I just showed you on the chromium where that was located. Now on chromium, it is 24, and it's 24 because it's located right about there, okay? So again, in sequential order, 1, helium over here would be 2, and then we have lithium 3, and then we have beryllium 4. So as we go down, okay, and we hit chromium, chromium is located right about there. It's 24. It's in our transition metals, as I mentioned. So we have 24. So we come over here and we put 24 where the atomic number is. There we go, 24. Now, our atomic mass, located right there, okay, on chromium it was 51.996, so we say it's 57. In very rare instances you will have to be very, very accurate, but for right now we're just going to be precise, which means that we're going to be pretty darn close, okay? So, our atomic mass is 52. Okay. Next thing, however many protons we have, that's how many electrons we have. So if our atomic number tells us we have 24 protons, we automatically have 24 electrons. So we'll write that down. Now, to find the neutrons. The neutron is located in the nucleus with the proton. There should be the same amount of neutrons as there are protons if we have a stable atom. However, with transition metals, especially with the alkali metals, they don't tend to be, and in this case, it's not. And I'll show you when we calculate in a moment, but just so you know, this is what we call an isotope. Okay, I'll explain that in a second. So now we're going to take this atomic mass and we're going to treat it like we're at a bargain bin store and they're charging us per pound. Okay, they know the weight of the basket that they're weighing everything in. So when they have their full weight, they subtract the known weight of the basket so that you don't pay for it. This is the same idea. So this is our entire weight, okay, and we're going to subtract our clothes, which are our protons. So we take 52 and we subtract it from 24. And I will write that right here. So we take 52 and we subtract it from 24. Okay, we all know we can't subtract 2 from 4, so we borrow, we turn that into 4, we turn that into 12, 12 minus 4 we know is 8, and 4 minus 2 we know is 2. And that gives us 28. So we know we have 28 neutrons. Okay, so we have 52 as our atomic mass, we have 24 protons, 24 electrons, and 28 neutrons. And like I had already said, chromium is not a very stable atom. It's a very friendly metal in our bodies. In the right concentrations, we actually need it, but it is not very stable, which sometimes is a very good thing. So again, getting ahead of myself, but so 28 neutrons, okay? So we know we have an isotope. Isotope meaning that it has more neutrons, does not have the same amount of neutrons as it does protons, okay? Not an ion. An ion has to do with the electrons and the valences, and if it has added or subtracted electrons. An isotope is when there are more or less neutrons than there are protons. If we don't have the same number of protons as neutrons, it is an unstable atom, okay? Very important. So, and it's a natural state. When we have them on the table, we are putting them in their natural state, their most common state. So the most common state for chromium is unstable. Okay. So, and then our electrons, we know we had 24 protons and 24 electrons. Didn't mean to trip anybody up there. There we go. So, atomic number tells us we have 24 protons, 24 electrons. We subtract our atomic mass from our atomic number, our number of protons, and it will yield our number of neutrons. Okay? So, before we do a calculation for lithium, we are going to talk about a couple of oddballs. And a couple of things that you're going to need to know as you start looking at this. And if you can visualize it, sometimes it helps as well. So right now this is hydrogen. And hydrogen is the weirdest element on the entire periodic table. It helps give us water, but the interesting thing about the molecule that is H2O is that it shouldn't exist, at least it shouldn't exist without a little more of a chemical reaction, an explosion, but it doesn't. So because hydrogen is so strange. So hydrogen has an atomic number of 1. But it also has an atomic mass of 1. If you take 1 minus 1, you have 0. I'm not sure where my video cut out, but I'll stitch it together best I can. So, what I was saying was that this model up here, which now I'm not sure you can see, there you go. So, this model up here has this really cool little nucleus right here, and then it has this orbit. To clarify the orbit, the valence, when we say that we're dealing with electrons orbiting, what we're really dealing with is a cloud because we're predicting all the places that they could be because they move so fast. So it's not really an orbit so much as a cloud, but we represent it as an orbit, or a valence. And this model right here in particular is what's called a Bohr's model. You'll deal a lot with these, but just so you can see this handsome fellow, there is Mr. Bohr, okay, courtesy of Bing Images. And he is the man who came up with this model to help us visualize what's happening at the atomic level. Okay, the second one that you're probably very used to seeing is one where here's our nucleus, and here's our orbits flying around. But what I did use to demonstrate is that with carbon, because it has 6 protons, it also has 6 electrons, so there are 2 in the first valence, 4 in the second valence. There is a very specific number of electrons that can be within each valence, and the outermost valence, whether or not it's filled or not, is what also determines the stability of an atom. So, good thing to know. So now we're going to calculate carbon. Okay, it's a good one to look at. It's very stable because we have how many protons? Let's see here. We know that we have 6 protons, right? And its atomic weight is 12. Got erased. Okay. Atomic weight is 12. So if we take 12 minus 6, we know we also have 6 neutrons. Pretty darn stable. And then 6 electrons that also fill up both of their valence shells, including the outermost shell. So, very stable. Okay, last one we're going to look at. Here is lithium again, in case you missed it. Seeing it constantly in your face like this. Okay, so there is our atomic number right there. We have 3. Remember that the atomic number can appear over the top as well. 3 right here, and that's our atomic number. And then that gives us 3 protons, and it gives us 3 neutrons, okay? So we take that atomic number of 6.941, and we write that as 7. And then we take 3 minus 7, which gives us 4. So we have 4 neutrons, 4 neutral particles. This is also an unstable neutron, or I'm sorry, an unstable atom. It is also an isotope. I hope that cleared things up for you, and I hope it demystified a few things about reading the atomic table. Okay, have a good day. Bye.